Now electric dipole. What is electric dipole? Electric dipole. A combination of two charges plus Q and minus Q are separated by a small distance, let this distance is d, constitutes an electric dipole. Electric dipole moment of this combination is defined as vector P is equal to Q into D. D is here vector and whose direction is from negative to positive charge. You can say the line along the distance of dipole here, negative to positive, is the direction of dipole. That means you can say if two charges, negative charge and positive charge, are separated by a small distance, let this distance is d, and then it will form a dipole. This is, it means two, and pole means your charges or your negative charge और पॉजिटिव चार्ज. तो ये पोल हो गया, इसको हम पोल की तरह डिफाइन करते हैं. मैग्नेट में जिस तरह से नॉर्थ पोल साउथ पोल होता है, ठीक उसी तरह से यहाँ पर हम लोग इलेक्ट्रिक डायपोल में नेगेटिव चार्ज पॉजिटिव चार्ज ट्रीट करते हैं. मैग्नेटिक डायपोल भी होता है जिसके बारे में हम लोग आगे पढ़ेंगे, बट हियर वी आर गोइंग टू कंसंट्रेट ऑन इलेक्ट्रिक डायपोल. देयर आर सो मेनी एग्जांपल्स ऑफ इलेक्ट्रिक डायपोल लाइक H plus Cl minus, this is Na plus Cl minus, this is the your combination of negative and positive charge, and this combination is called dipole. Here D is a vector whose direction is from negative to positive charge. The line along the direction of dipole moment is called axis of dipole. This is called the axis of dipole. Now we are going to find what will be the electric potential due to dipole. Now let us see electric potential due to dipole. Electric potential due to a dipole. डायपोल के कारण इलेक्ट्रिक पोटेंशियल क्या होगा, इस पे हम लोग बात करते हैं. लेट दिस इज द डायपोल, नेगेटिव चार्ज and this is positive charge, and distance between the charge is here d, and we are going to concentrate at point P, any arbitrary point P, at which we are going to find the potential. Now here we are going to find the electric potential due to dipole. Dipole is a system if two charges are placed at a very small distance. This is negative charge, this is positive charge. Magnitude of both charges have same, but sign are opposite. Let the distance between this is your d. मान लिया ये जो distance है वो d है. That means if this is mid point, मान लिया इसको हम mid point ले लेते हैं, तो ये हो गया आपके पास distance, this is d by 2 and this distance is d by 2. And let this is p, p को हम इससे ज्वाइन कर देते हैं, you will get like this. अब इसको P से ज्वाइन करने के बाद ये आपके पास आ गया, एंड हियर लेट दिस इज थीटा, और इसको इलोंगेट कर देते हैं ऐसे, और इसको हम ज्वाइन कर देते हैं, तो दिस डिस्टेंस इज लेट r1 एंड दिस डिस्टेंस इज लेट हियर r2, और यहां से लेकर मान लिया इस पॉइंट को हम ले लेते हैं m टू P इज योर लेट r. अब क्या करते हैं, A से A डैश, इस पे एक परपेंडिकुलर देते हैं हम लोग. लेट दिस इज A डैश एंड दिस इज A डैश, तो A डैश परपेंडिकुलर है, दिस इज थीटा, तो ये भी आपका थीटा हो गया. नाउ B2, देखिए PM पे एक परपेंडिकुलर डालते हैं हम लोग, दिस इज परपेंडिकुलर, दिस इज, एंड दिस पॉइंट इज लेट B डैश, इसको हमने B डैश ले लिया. दिस इज ऑल्सो थीटा, ये भी थीटा हो गया आपके पास. अब देखिए ये इसका हॉरिजॉन्टल कंपोनेंट है, दिस इज योर हॉरिजॉन्टल कंपोनेंट, d by 2 का ये हॉरिजॉन्टल कंपोनेंट है. दैट मीन्स MA डैश, दैट मीन्स A dash is the horizontal component. That means you can write this is d by 2 cos theta, d by 2 cos theta, and here this is also your horizontal component. ये भी इसका horizontal component है, 90 डिग्री है तो ये भी इसका horizontal component है. That means MB dash is अगेन d by 2 cos थीटा, ये भी आपका क्या हो गया d by 2 cos थीटा. एंड हियर फ्रॉम ज्योमेट्री से आप देखेंगे तो AP is approximately equal to your PA dash के इक्वल है. AP जो है ये इसके इक्वल है. दैट मीन्स यू कैन राइट AP R1 is equals to here M, इसको लिख सकते हैं हम लोग PA को क्या लिख सकते हैं PM प्लस MA डैश लिख सकते हैं. PM देखिए ये दोनों हमने क्या किया इक्वल है. हमने किया कि AP is equal to PA dash and PA dash is equal to PM plus MA dash. PM is here R and MA dash is here d by 2 cos theta and this is your R1. Next R2 के लिए देखिए क्या लिखेंगे. तो now here from geometry PB dash is approximately equal to your PB के क्या होगा इक्वल होगा. and here PB dash is equal to PM minus MB dash. PB dash को हम लिख सकते हैं ऐसे. तो PM is here R minus this is d by 2 cos theta. This one is, and this is equal to here your PB, that means this is R2. That means R1 is here this one, this value is R1 and this value is here R2. तो R1 और R2 आपके पास आ गया. R1 और R2 को हम यूज करके हम लोग आगे फाइंड आउट करते हैं. Now potential due to negative charge is here, let V1, and potential due to here positive charge is here V2. Now potential is a scalar quantity, so net potential will be V is equal to V1 plus V2. Now we are going to evaluate what is V1 and what is V2. Potential at P due to negative charge. Potential at P due to minus Q. Minus Q is equal to here let V1. तो हम इसको लिखेंगे minus Q by 4 pi epsilon naught into 1 by your R1. This is R1 and R1 is here AP. AP भी लिख सकते हैं, R1 भी लिख सकते हैं. That means this is equal to minus Q by 4 pi epsilon naught and R1 is here R plus D by 2. R plus D by 2 cos theta. This is R1. And potential, next, potential at P due to positive Q is V2 and V2 is equal to here Q by 4 pi epsilon naught and this is 1 by R2. This is positive और ये पॉजिटिव वैल्यू है तो इसको हम यहाँ पे लिख देते हैं. दिस इज Q by 4 pi epsilon naught into 1 by this is R and minus D by 2 cos theta. This is here V2. For V2 R minus D by 2 cos theta. For V1 this is R plus D by 2 cos theta लिखेंगे हम लोग. And net potential is V and V is equal to V1 plus V2. V1 that means V2 plus V1 or V1 plus V2 you can write. That means this is equal to Q by 4 pi epsilon naught and this is 1 by R minus D by 2 cos theta plus, and this will be minus here, minus sign, so minus Q by 4 pi epsilon naught into 1 by R plus D by 2 cos theta. This is, that means V is equal to Q by 4 pi epsilon naught is common, इसको हम कॉमन ले लेते हैं. Now this is your A square minus D square by 2 square. This is 2 square, that means 4 and this is cos square theta. ये हो गया cos square theta and this is here R plus D by 2 cos theta and this is minus R plus D by 2 cos theta. ब्रैकेट क्लोज. नाउ माइनस आर प्लस आर कैंसिल आउट और इसको हम ओमिट कर सकते हैं बिकॉज d इज वेरी स्मॉल. d वेरी स्मॉल तो d स्क्वायर जो होगा वो और छोटा हो जाएगा, और छोटा आपका हो गया, तो इसको हम नेग्लेक्ट कर सकते हैं. दिस वैल्यू इज वेरी वेरी नेग्लिजिबल. सो इसको हम ओमिट कर देते हैं. तो इसको ओमिट करने के बाद आपका जो रिजल्ट आएगा, दैट रिजल्ट इज हियर q बाई 4 पाई एप्सिलॉन नॉट, and this is here d by 2 cos theta. That means this is here d cos theta, and divided by this is r square. This is the value of your net potential due to dipole at any point p, and q into d is your dipole moment. इसको हम dipole moment बोलते हैं. तो q into d, this is p. dipole moment को p से डिनोट करते हैं. This is p cos theta divided by 4 pi epsilon naught r square. This is the net potential. Now here net potential is V is equals to 1 by 4 pi epsilon naught, and this is here P and cos theta divided by r square. And from diagram, this is your, let minus q, this is plus q, and this is any arbitrary point, and this angle is theta. If theta is 0, that means this P will be on the axis of dipole. ये axis of dipole पे lie करेगा. So that means you can say if theta is equals to 0 degree, P lies on axis of dipole. So axis of dipole, that means P will be here. P will be here in that case, and put the value here. You will get V is equals to 1 by 4 pi epsilon naught. This is P. Cos 0 is your 1, and this is r square. That means this will be P by 4 pi epsilon naught r square. This is the net potential. If theta is equals to 90 degree, that means this will be perpendicular bisector. यहाँ पर, that means this is perpendicular bisector. At this point here, if theta is 90 degree, then put here V equals to your 1 by 4 pi epsilon naught, and this is P cos 90. Cos 90 is 0. That means net potential will be 0. And this is the two special case of dipole when P lies at 0 degree or 90 degree. Now next topic is torque on an electric dipole placed in an electric field. Let this is uniform field. Uniform electric field, that means positive charge is placed here, and this is electric dipole. This is negative charge and this one is positive charge. Positive charge will repel, ये इसको repel करेगा, and negative charge को ये attract करेगा. That means, and this is the axis of dipole. Let this is axis of dipole, and electric field is like this, and this is here theta. This angle is here theta. Let this point is A and this point is here B. नेमिंग कर दिए, फिगर बना दिए हम लोग. Consider an electric dipole placed in an uniform electric field E. A dipole consists of negative and positive charge placed at A and B respectively. The midpoint of AB is O. Let this is O, and length of dipole is D. That means this will be D by 2 and this is D by 2. D by 2, D by 2. Whole length is D. Suppose the axis of dipole AB makes an angle theta with the electric field at certain instant. The force on the charge Q is here. Positive charge Q is F equals to QE. That means F equals to QE is here force. And force on negative charge is here F2 here. Let this is F1 and this is F2. F2 is here minus QE. This is minus Q is here opposite direction. The force on plus Q and force on minus Q will create a torque, and torque, that means here torque is equals to R cross F, and R is the distance from axis of rotation. This is axis of rotation. द टॉर्क ऑफ F अबाउट O इज, देखिए दोनों टॉर्क जो होगा इसका जो एक्स रोटेशन होगा वो क्लॉकवाइज होगा, ये दोनों मिलाकर ये क्लॉकवाइज, सो टॉर्क विल ऐड, यहाँ पे दोनों टॉर्क को क्या करेंगे हम ऐड कर देंगे। तो टॉ वन हम यहां लिख लेते हैं, दिस इज टॉ वन इज इक्वल टू हियर OB क्रॉस, दिस इज OB क्रॉस हियर F1, दिस इज F1, and tau 2 is equal to here this length OA, that means OA cross F2, both F1 and F2 are equal, तो F1 F2 इक्वल है तो हम लोग इसको लिख सकते हैं, दिस इज इक्वल टू tau 1 is equal to OB and this is QE, and tau 2 is equals to OA and this is QE and this is negative minus QE, इसको हम माइनस दे देते हैं यहां पर इसके लिए। Now from this figure tau 1 is here QOB cross E, you can write OB is this distance and cross product E, and Q2 is negative direction, this is minus Q, so minus Q OA cross E, so you can write, ये नेगेटिव साइन हटाएंगे तो ये आपका OA AO हो जाएगा, ये OA जो है वो AO में कन्वर्ट कर दिए, so this is T2 tau 2 is equals to Q AO cross E, net torque will be tau 1 plus tau 2, that means Q OB cross E plus Q AO cross E, OB is in this direction and AO is in this direction, तो you can add both, दोनों को ऐड कर देंगे, that means you can write this is Q and this will be your AB cross E, you can write, that means AB is what, AB is the length of this dipole, तो AB के लिए ये dipole का लेंथ हो गया, that means you can write this is Q and D, this is QD is equal to here this is vector and cross E, ये हो गया, तो this is DE cos theta, D cross E means DE cos theta, और you can write this is QE, तो इसको हम ऐसे लिख सकते हैं QD को हम P लिख सकते हैं, डायपोल मोमेंट है, this is dipole moment, so you can write here this is P cross E, that means net torque is equal to P cross E, net torque is equal to P cross E, or you can write PE sin theta, that means you can write tau is equals to PE sin theta, where P is dipole moment, E is electric field and theta is the angle. Now relation between electric field and potential, here electric field vector quantity and potential is scalar quantity. Suppose the electric field at a point whose position vector is R due to a charge distribution is E, and this is your electric field due to a charge distribution whose at position your R vector, and the electric potential at the same point is V. Let this is here, this is position vector, this is position vector, this is your electric field and this is your electric potential, Now suppose a point charge Q is displaced slightly from R to R plus dr, R to here R position vector to R plus dr, dr is small distance, dr shift किया गया है a charge Q, then the force on the charge is equal to F is equal to Q into E. E is electric field, F is the force, and the work done by the electric field during the displacement is dW, and dW is equal to, this is F dot dr, here F is force and dr is displacement. Now F is here Q, E, and this is dr, you can write. Now change in potential energy, du is equals to negative of work done. That means you can say this is minus q e dr. You can write. And here change in potential is equal to dV. dV is change in potential, and dV, this is V, dV is equals to du by q. du is here minus, this is minus q e dr divided by q. Q cancel, that means you can write dV is equals to negative of e dot dr. Now you can integrate. अब इसको इंटीग्रेट कर देते हैं. इंटीग्रेट फ्रॉम v1 to v2 and here r1 to r2. Now dv इंटीग्रेशन इज v. dv का इंटीग्रेशन आपके पास हो गया v. अब dv के लिए हम v लिख दिए. and now put the limit. limit is here v1 to v2 and here minus e dr integration is r. Now this is here r1 to r2. That means this value will be equal to here v2 minus v1 is equal to minus e, and this is r2 minus r1. Now close the bracket. This is your relation between potential and electric field. This will be vector sign. This will be vector sign here. You can write v2 minus v1, where v1 and v2 are the potential at position r1 and r2, is equal to negative of integration e dot dr, and this is r1 to r2, where v1 and v2 are potential at r1 and integration e dr r1 to r2 limit, and this expression can be written as your vr negative of r1 to r2 e dot dr. This is the relation between potential and your electric field. Now if you work in Cartesian coordinate system and E is here let EXI plus EYJ plus EZK. This is I, J, and this one is K, and dr is here. This is electric field and this is dr here. dr is let dxi plus dyj plus dzk. Let this is here. Then dv is equal to negative of minus ex dx minus ey dy minus ez dz. This will be your relation. If we change x to x plus dx, if we change x to x plus dx, keeping y and z constant, that means dy is equals to dz is equals to 0 because it is constant. Then ex, then you can write ex, that means you have to use here partial differentiation, and it will be here negative of del v del x. Similarly ey is equals to negative of del v del y. Next ez is equals to next del v del z. This is your expression, and for this expression you have to use partial differentiation. What is partial differentiation? इस पे हम लोग बात कर चुके हैं in your differentiation chapter. आप उसको देख सकते हैं and we can proceed for this.